All right, so in this video, we're going to be looking at rational exponents, but we're going to be looking at the rewrite of it. So we're going to rewrite them with or without exponents and rewriting them with positive exponents. So we want to start off and saying, okay, we are acknowledging that we're working on rational exponents. And our first example and bit of direction comes with this. It says rewrite basically the following rational exponent and expression without rational exponents. So rewrite without rational exponents. And what that initially means is it says basically take this and write it as a radical in our traditional form there. So whatever your numerator is, that's going to be your exponent here. Whatever your denominator is, that's going to be your index here. And there you go. Once you write it in this form, it's no longer in a rational exponent. The next bit would look something like this. Rewrite with rational exponents. So this is actually the reverse of this one up here, is that if I give you a radical, that you then say, okay, well, these all have an exponent of 1. So my numerator is going to be a 1. And there is my denominator, which is my index out here. And that is then raised to this power. So we have, that is one way that you'd be able to see it and how you'd go about doing it. So the next component that we though want to look at is our negative rational exponents. So we've seen some of these things like this, but what happens if our exponent is negative? What does that mean and how do we work with it? So the directions would say something like this. Rewrite with a positive exponent and simplify if possible. So when you're giving your negative exponent, what they basically mean is they want you to write it in this format here for that negative exponent. Thus, if you notice, it now has a positive exponent in the denominator. So if it's a negative exponent and when it's up here, when a is in the numerator, then it becomes a positive exponent when a is in the denominator. Feel free to pause these videos at any time to be able to copy the stuff down. So let's look at some of our examples. So this is one example of how you would see this negative exponent. And so initially you will just write it in the denominator. Notice my exponent is now positive. And then from here I'm just basically simplifying. Rewrite it as my 2 and my 1. Square root of 9 is 3, and there you go. Another example would be this one here. So since this entire expression here is raised to the negative exponent, we put the entire thing in the denominator because it's in the parentheses, so that's what it applies to. And we have our positive exponent. This isn't going to be able to simplify, so we can just leave it in this format. Again, feel free to pause as needed. So if you have something that looks like this, again, we put in the denominator, positive exponent, and then we look at trying to simplify. So the nice thing is, remember, you can do either or as possible. If you need to square this number first and then take the third root of it, you can. It just kind of depends on what this number is and which way it allows you to be able to simplify it the easiest. Since it's 64, I can automatically take the cube root of it, giving me 4, which then I just square and simplify down to 16. So write with the positive exponent and then simplify. So in this example, we want to look at the fact that each component has a different type of an exponent and thing going on. So up here you use parentheses and they were all connected. Down here, the 4 is raised to a 1. It is not connected to this negative 2/3. It is not connected to this 1/5. As is this y is not a negative exponent, it's a positive. So when you see ones like this, you have to recognize that the exponent only applies to what is next to it. And if that next to it happens to be a parentheses, then only what's inside of the parentheses follows the rules of that exponent. So the 4 is just going to be left by itself. The x to the negative 2/3 is what is going to be the reciprocal and put down into the denominator. And then since this guy's positive, he's like, hey, I am positive here, don't move me. And then we just multiply straight across and get our simplified answer. So the last example of how you'll see these type of rewriting with positive exponents might be something that looks like this, where we have already a fraction with a negative exponent. And now here's kind of the nice fun thing you can do is you flip it. Because the opposite of 64 over 1 is 1 over 64, then the opposite of, well, a over b, the reciprocal, basically same thing, is going to be b over a. And that flipping it eliminates that negative exponent. So by flipping these, we eliminate the negative exponent. And then if we wanted to, if it worked out, we could apply this to both the numerator and the denominator and simplify, but it's not, so we're leaving it the way it is. All right, so those are some basics of working with negative rational exponents and just rewriting exponents in general. All right, I hope this helped.